Okay, we're going to be discussing the absolute value graph. And the absolute value graph looks like this. It looks like a V graph. Now I'm using the scissors. Okay, but it's an absolute value. Absolute value is a V. It's not a straight line because it comes down and it goes back up again. So a lot of students, when they graph it, they'll only get one side and they keep forgetting that there's another side to it. Now if you notice at the very crook of this is something called the vertex. This is where, if you look at the scissors, let me bring it up just a little bit more, you can see that this pretty much acts as what we call the vertex. Okay, that's what this center point is called. Now, absolute value can be wide and it can be very narrow, depending upon a couple things with the graph. But for now, so we can get very narrow with our absolute value graph, and we can get very wide with our absolute value graph. Another thing that could happen is that it could get upside down as well. And again, it can get very wide or very narrow when it's upside down. But again, it's still a V graph. That's sometimes what we call it. It's still a V graph. It forms a V whether it's upside down or it's right side up. So again, please understand, it's not a straight line. Yeah, this is straight, but then it comes down and then it goes back up again. So this is not a straight line. And we're going to graph it, and I'm going to make sure that you know that we're going to find both sides of this if you follow what I do on this video. On this video, I'm going to make it really easy for you to find both sides of this without having to do a lot of work or to guess. This way, when you graph it, you don't get one side. And that's what this video is going to be about. In this video, we're going to be graphing absolute value functions. It is a V-shaped graph. It is not linear, meaning it is not a straight line from beginning to end. It is V-shaped. It is of the form, now there are two forms that you could see, f of x equals the absolute value of x, or you may see it as y equals the absolute value of x. Now understand that that is the basic form or the basic format. From here you can expand on it and make this go left, right, up, down, flip it upside down as well. This is the basic form of the absolute value function. We're just going to go straight into this video. We are going to talk about this one. This is h of x is equal to the absolute value of x plus 3. It's a very nice problem to start out with. For this problem, what you want to do is set the inside of the absolute value problem equal to 0 and solve for the variable. The inside of the absolute value in this case is x plus 3. So when we say set the inside equal to 0, that's exactly what we mean. Only this part right here and all of it. Here is our problem. We're setting the inside x plus 3 equal to 0. This is always step 1. Set the inside equal to 0. From there, you're going to solve for the variable, in this case x. So we're going to take our problem, subtract 3 on both sides, and get x equals -3. This is what we call the vertex of the graph. That is that center point where the V starts at. That's pretty much where it is. That's the notch or the center point of the graph. This is a key idea in this class. You will see this word again later on this semester. Again, this is the vertex. This is the center point, the notch of the graph. Using this point, we can take this problem and graph it correctly. Step 2. This number that you found, the -3, x equals -3, is going to be placed into the middle of our T-chart or just chart, however you want to say it. Now, a lot of us are used to doing the charts where we just go X, Y. If you do that, that's fine, but understand there's not a lot of places where you can put your work. So I'm going to be doing this problem a little bit differently. A student of mine a long time ago showed me how they did their problem when they did the T-chart. What they did is they made a middle portion here, and that way they could put all their work in here, and it doesn't go all over place, all over your paper. And I thought that was genius. This is the T-chart that we're talking about, or just a regular chart to get your points. Here is your chart. When you found the x equals -3, this -3 is the middle of the graph. Therefore, it will be the middle of your chart. What I expect is to have numbers 2 above and 2 numbers below this -3. And from there, we can actually get the symmetry of the graph and get the graph done correctly. So the number that you got in step 1, x equals -3, is actually the middle of the graph, which means that it goes into the middle of your chart right here. We're going to do the work for this one. That way you can see the middle when it comes to this chart. The -3 that you found in step 1 is the middle of the graph, which means it will go into the middle of your chart. You will find 5 points. -3, 2 above and 2 below that point, or in this case, 2 to the left and 2 to the right of your point on the graph. Again, these are your x values. And it doesn't matter the order you put them in. However, I would put some sense of order to it. The number that would be before -3, I would do something like this. There would be a -2 and a -1. After 3 would be a -4 and a -5. You really want to put them in some type of order here. That way you will see some type of pattern here. If you put these numbers in willy-nilly, you're not going to see a pattern, and you're not going to know if you really got this right. So putting them in, whether it's from -1, -2, -3, -4, -5, or you went from -5, -4, -3, -2, -1, does not matter. But put them in some type of order here on this side, on the x's, and again, you will see a pattern arise over here. The reason why we're using the vertex is because I want the least amount of numbers to plot. And this will get me there faster on the graph. If you pick any numbers that you want, you may end up getting a straight line, and that's not the point. You want the graph. Another thing about getting the middle of the graph is that the graph will be relatively small on your paper when you graph it. You won't have a large graph, and you won't have large numbers. What I'm going to do is take this -1 and I'm going to plug it into this value right here. So I have the absolute value of -1 plus 3. Whenever you have anything in here more than one number, you need to actually fulfill this. Remember, you have to do parentheses first. Again, absolute value acts like a parentheses. You got to work this first if you can. And we can do that here because these are just numbers. So what you have is 3 minus 1. So you have the absolute value of 2. And the absolute value of 2 is just 2. So you can put your final answer here in the y column. Do the same thing for the next number, for -2. I have the absolute value of -2 plus 3. That number is going to give me 3 minus 2. Absolute value of 3 minus 2 is 1. So we have the absolute value of 1. The absolute value of 1 is 1. Next number is -3. I have the absolute value of -3 plus 3. -3 plus 3 is 0. Now that you simplified, you can go ahead and use the absolute value. The absolute value of 0 is 0. Next number, -4. I'm going to plug that in for our x value once again. So -4 plus 3 gives me, well, this is 3 minus 4, or -4 plus 3, however you want to read it, but that gives me a -1. Now that you got a single answer, the absolute value of -1 is 1. So you have to work the inside completely, get your number, and then take the absolute value of your answer, and that will be your y value. Let's do it one more time. Add the absolute value of, again, x is equal to -5 plus 3. Plus 3 is from this right in here. -5 plus 3 is a -2. We're still inside the absolute value yet. Now that we have the absolute value of -2, from here we can work this out. What's the absolute value of a -2? And we know that's 2. Notice, one more time, if you put your numbers in some semblance of order on this side, on the x, you will see a pattern start to arise on the right. If this is 0, these two numbers should be the same when you do this method. And then the other two should also be the same on this method. If you want to put these in terms of points, your x goes first, so you have the -1, and your y goes second, that's 2. So right now, you have the point -1, 2. It's just that your work is confined in the middle and it's not all over your paper. You have -2, 1. Next point, -3 was my x, 0 is my y. Then we have -4, 1. Again, doing in terms of x, y, x is -5 and y is 2. All your work is in a nice little chart. You can see all your work done in the middle, and on the side you can write your points. So you don't have to do it this way, but it does help out a lot of people as far as being nice and orderly. Alright, so we have our graph, and we are going to graph this problem. Understand that if I give you an absolute value graph, what should pop in your head is that it should be a V graph. It should look like this. Again, it can be really narrow or it can be really wide. You do not have to put your points here. I'm just putting them here because my other notes are on a different page. So I'm going to be graphing all of these points onto this graph. Understand that the first value is your x value of the point, and the second one is your y value. I'll try going through this to make sure everybody remembers how to graph. You have an x of -1, so on the x-axis find -1. Boom. It says your y is 2. Y being in the upward and downward notion. Since I want to go to a +2, I stay where I'm at with the -1 and I simply go up 2 units. And there you've plotted your point. Doing it again, since some of us are rusty, I have x is -2, so somewhere on the x I find -2 and I stop. I found it. Then I go up or down according to the number on the y. The y says a +1. I go to +1 once I'm at the -2x value. So I'm at the -2, I'm at the 1 value, and this is my point. Next one, I have the -3, 0. So go to x equals -3, and the y is 0. When you're on this x-axis right here, this is when y is 0. Take a look at your barometer, because that's really what the y-axis is. And on the y-axis, 0 is where this notch is, where the x and y meet. So 0 is here, but understand, this is all y equals 0. And I'm just going to stay right here. 0 meaning I don't go up or down when I'm on this -3. I simply just stay put. Next number is -4, 1. So on the x-axis, I go to -4. And then my y value says I go to the +1, so I just mark my point. -5, 2, x is -5. From -5, I go up 2 units. And if you notice on the graph, I have formed a V graph just like I said we would. So this vertex right here is really important in order to graph the absolute value correctly. From here we're going to connect our dots, but you're going to go through them because remember, these lines go on forever. And so you just don't connect the dots and go, we're done. In other words, I don't want to see this on your graph because I would mark you wrong. it doesn't stop here. You can pick a whole bunch more numbers, which is why you put the arrows on it, because I could pick more numbers and extend these lines out. This is your absolute value graph. This is the absolute value of x plus 3. Let's go a little bit past this. Now that you graphed it, tell me what the vertex is one more time. And the vertex is always going to be a point. So from this graph, we can find the vertex. And again, what is the vertex? It is the notch. Where did it change direction? Where it went down to go up? Where is that? What is the name of that point? And that point is called -3, 0. So that first number that you put in the center of the chart is the center of the graph. The center of the graph is the vertex. So that number followed you throughout step 1. Hence, your vertex is -3, 0. Not only can you find the vertex, but you can also find the domain and the range from this graph. When you find the domain and the range, you're using interval notation. So the vertex is a point, and all points use parentheses. Domain and range use interval notation. So this is, again, where you're going to be using bracket or parentheses. So points and interval notation are not the same. When you say vertex to most math people, we understand it's a point. When we talk about domain and range, we understand it's interval notation, and so things get a little different, even though it looks the same to most people. So this is basically your graph, the way that it looks like. It's a V graph. Pretend you're Superman, and because we're dealing with X values, we're going to deal with this graph the X way, which is which way are the X's pointed? Well, they're pointed this way. The X's are pointed this way. So we're going to spread them out, pretend you're Superman, and bend it out. And what you form is a straight line. And so you can definitely tell that when I form the straight line, this graph goes off to -infinity. And then it also goes to +infinity. So what this graph is telling me is I can use any X value for this graph and it will give me a Y answer. Any X will work. So taking it back, as we can see, this graph is going up and up and up. But not only is it going up and up and up, it's also going outward. So as it keeps going outward, we can see that it is taking on all of the X's on the number line, which is why the domain is going to be from -infinity to +infinity. So one more time, looking at the interlude that we just had, our domain is going to be from -infinity to +infinity, or you can write the set of real numbers, whichever one you want to use, but your book will use this one. Again, any X I use will work no matter what. The range, on the other hand, is a different story. Let's watch. Once you understand that it starts at 0 on the Y-axis, you could pretend you're Superman once again, because we're dealing with Y's, and you can close them up so that they are close together. This will be your Y. And what happens is we are starting at 0, and you notice the arrows, both of them, point up forever, and that is the +infinity direction. So you can pretend you're Superman, put them together, and you can straighten them out once again to get your graph. But you notice that it's starting at 0 where our graph starts at, and then they continuously go up forever. But you have to remember you're talking about range, and range is always in the upward or downward notion. In this case, we start at the vertex and work our way up. And that goes to +infinity. Okay, welcome back. So hopefully that made some sense to you. If not, let's go through this graph one more time. You always read graphs for the Y, for your range, from the bottom up. Okay, so you read it from the bottom. So where does my graph start at? Well, it starts at, now most students would give me a -3. Please understand that we're talking about the Y-axis, and the Y-axis, it starts at, take a look, it starts at this little juncture right here called the origin, which is 0. Do not look at the X value. These are confusing, kind of look at, if you have to cover it up, that's fine. And just look at this. Where does it start at? And it starts at y equals 0. Now it starts at 0, and then it keeps going up forever. Remember what I did in the video? I just took the V-graph and I smushed them together. Pretend you're Superman and you put them together, and they point upward. They point that way. So my range is from 0 to positive infinity. If you want to put a plus sign there, you can to denote it, but you don't have to. The infinities, as you know, always, always, always get parentheses. Again, just follow this lovely curve of your infinity. For your range on the 0, if it touched 0, which it did, it touched this point right here, it touched the line. Because of that, it gets a bracket. All of your numbers will get a bracket. Only the infinities will get the parentheses, because your numbers touch the graph and are included as part of that graph. So you have to include it, therefore you will use brackets. So getting this straight as far as domain and range is interval notation, and understanding that vertex is a point is a bone of contention with people, but please try to make sure that makes sense to you. Vertex is a point, domain and range is interval notation. Let's look at this problem from a different perspective. Let's go back to analyzing it without a graph. If we're given the problem h of x is equal to the absolute value of x plus 3, automatically, you should memorize it, the fact that the domain is all real numbers, always. So that's not the problem for the domain, it's going to be the range. Let's talk about the range of this problem. Step 1, what is the floating number? We've gone through this several times, so hopefully you remember. Floating number then must be the number that is being added or subtracted to. Now understand, this is on the outside of this absolute value. Do you see anything being floated on the outside of this, not the inside? If you don't, that's because there's an imaginary 0 that's sitting out there. So adding or subtracting, it doesn't matter if you put a plus 0 or a minus 0, it doesn't matter, because 0 doesn't take on any sign. If there is no number, again, it's an automatic 0. So 0 is your floating number. So you found your floating number. Great. Now that you found your floating number, that's only one step. We know that 0 in and of itself is going to be one of the numbers we're going to use for our interval notation for range. Let's go to the number multiplying against the absolute value. Well, I don't see anything multiplying against this absolute value, but there is, you just don't see it. And that's a positive 1. So there is a positive 1 times this absolute value plus your floating number. So what does that 1 do for us? Remember, no number in front means it's a 1, and in this case it's a positive 1. That's nice that we denoted the number, but really our concentration comes down to this plus sign for our range. This plus sign denotes positive infinity. So it's going in the positive direction for our y's. So the positive sign tells me which infinity I'm going to. And remember, whichever order you do these does not matter so long as you get them both done. Now that I got 0, and I know the positive means positive infinity, we have both values to do our range. Now it's time to put it together. Remember how this always works in interval notation. It goes from small to large. Which of these two numbers is the smallest? Which of these two is the largest? Well, hopefully you know the smallest is 0 and the infinity is the largest. Putting them in the right place is key, because I will mark you wrong if you do it backwards. From there, it's just a matter of determining what do I use. Well, remember, once again, infinities has a built-in parentheses, so we put a parentheses on our infinity. When it comes to a number, we always put a bracket on the number because this number is always included with our answer because it touched at y equals 0. So this is your range. Again, please remember for my domain, we didn't really have to find it. It is understood, it is all real numbers. So what it's saying about this graph is that I can, oh wow, puberty, holy crap.